This is Learning Assessment Problem E21. In this problem, we'll apply Ohm's law and the various power relationships in a resistor to determine various aspects of each circuit. In the figure A part of the problem, we're asked to find the current I in this loop and the power absorbed in the 40 kilo ohm resistor. We have a voltage across the resistance V sub R, and initially we recognize that V sub R is equal to 12 volts, the voltage of the source. So we can use Ohm's law. I is equal to VR divided by R. In this case that will be 12 volts divided by 40K, and that will be equal to 0.3 milliamps. So that is the value of the loop current in the circuit. Now we're asked to determine the value of the power dissipated or absorbed in the resistor. So P sub R in one form would be V sub R times I sub R, which is 12 volts times 0.3 of a milliamp, or P sub R is equal to 3.6 milliwatts. You might try the other forms of the power expressions for a resistor and determine that this same value is obtained. For the part B circuit, we have a current source and again a voltage developed across the resistor V sub R, and we are asked to find the voltage across the current source V sub S and the power supplied by this current source. So we have V sub R is equal to V sub S is equal to I sub S times R. This is Ohm's law for the resistor. The source current is 0.6 of a milliamp and the resistance value is 6K. So therefore V sub S is equal to 3.6 volts. Now we'll calculate the power supplied by this source, and that will be V sub S times I sub S, and that is equal to 3.6 volts times the source current, which is 0.6 of a milliamp, and this is equal to 2.16 milliwatts. This power is being supplied by the source because the current flows out of the positive terminal of the polarity of the voltage across that source.